Good morning, everyone. I'm Muthukumar Murugan. I work for the CT office at HP Storage. Today, I'm going to talk about data protection in OpenStack. So this is the agenda for my talk today. I'm not going to be selling any HP products today. So all I wanted to do was share some thoughts about how data protection can be achieved in OpenStack. So first, I'll be briefly talking about how data protection is realized in today's enterprise world. And then I'll talk about what are the current options and mechanisms to achieve data protection in OpenStack. And then finally, I'll talk about a few issues and potential future directions to realize a comprehensive data protection strategy in OpenStack. So let's first talk about how data protection works in today's enterprise. So first of all, why do we need data protection, right? So today we live in a world where we sort of virtualize everything. And when we talk about clouds, be it private or public, the scale at which these clouds operate is really enormous. So we're talking about thousands of physical machines and tens of thousands of virtual machines that run on them. And each of them is going to generate data, process data, and the data is growing at an explosive rate. So when all this is happening, so the resource allocation and creation is happening automatically, and managing all these resources is a nightmare. Also, the data that each VM generates is critical because loss of any data implies loss of business continuity. And in a cloud environment, potentially there are multiple enterprises or multiple business units of a single enterprise, and the data is really valuable. So people are getting more nervous. Everybody is getting nervous. Data center operators, system administrators, the users of the data centers, everybody is getting nervous. So besides the value of the data and complexity of managing the huge volume of data, there are also regulatory compliance requirements which mandate that data be managed in a specific way. For example, in a financial institution, you might have to retain the data for a certain period of time. The data management cannot be manual. It has to be automated, and nobody can actually access the data. And all sorts of security and privacy issues arise. So in a sense, I think we can all agree that in an enterprise environment, data protection is critical. So typically, in an enterprise environment, snapshots and backups are the two main mechanisms to realize data protection. Most of the storage arrays today support point-in-time snapshots, so you can basically create a snapshot, roll back to some certain point in time, and all that is already supported in storage arrays. Besides volume-level snapshots, so applications also can generate, initiate snapshots, and typically the applications queries, they flush all the data to the disk, and then they create, the snapshot is created. Another mechanism to realize data protection is backup. Backup can be a full volume backup where the entire volume is backed up, or it could be incremental where only the data that is changed after the last backup is backed up. When it comes to backup, recovery performance is critical, and it is typically quantified by recovery time objectives, which is the time it takes to basically recover a volume from a backup. And recovery point objectives are also important, like which dictates how often you basically do the backup. And since backups are copies of a volume, they have enormous potential for deduplication, and most backup systems do deduplication to basically save storage space. They also use compression sometimes. And to prevent data loss because of an entire data center failing, so data is typically replicated to a remote site, and that helps with disaster recovery. Now let's look at some of the options and capabilities that OpenStack provides for data protection. So OpenStack does support snapshots, so there are both instance snapshots and volume snapshots being supported today. When it comes to instance snapshots, so each Nova instance can actually initiate the snapshot. So basically, from inside an instance, you just do an fsync and flush all the writes to the disk, and then you create a snapshot image from Nova. And that image could be uploaded to Glance, which can later be rolled back to the volume. And when it comes to volume snapshot, it relies on array support. So it could be as simple as issuing a snapshot create command from Cinder. And Cinder, this is the Cinder backup flow. So basically, when there is a backup call from a Cinder client, the Cinder backup manager picks up the call and talks to the block driver, which has a backup function defined. And the block driver, in turn, calls the backup driver, and there is a backup driver per backup service. So today, Cinder backup basically has 3 different backups drivers supported. So one is Swift, the other is Ceph as a backend, and the third one is IBM Tivoli. So today, Cinder backup is supported only for full volumes, so you can only do full volume backups, and backup of live volumes is basically not supported. You will have to basically detach the volume from an instance and then do the backup. So when you initiate a backup job, so basically the volume driver mounts the volume on the host that is doing the backup, and then the backup driver reads the entire volume and uploads it to the backup storage system through whatever interface the backup system provides. And now let's look at some of the issues with data protection in OpenStack today, and some potential future directions that I think can enable better data protection strategies in OpenStack. So like I said, so Cinder backup driver is the one who actually does the backup. So when we talk about OpenStack in general, we talk about software-defined everything, right? So when it comes to Cinder, it is software-defined storage. So a critical component of software-defined anything is separation of control plane from the actual process itself. But today, that is not the case with Cinder backup. So if Cinder backup dies, the backup job also dies with it. What should ideally happen is Cinder backup should initiate the schedule of a backup job, and then just get out of the way of the backup job, and the backup service should basically do the backup job, so that even if Cinder dies, the backup job still completes. And also, because live backup is not supported, so if Cinder dies, the instance is basically cannot be used, and there needs to be a manual intervention to take care of that. And so this separation of control plane and support of live backups is critical for realizing the real goal of OpenStack. And when it comes to snapshots and backups, so applications can also initiate this backup and snapshot. So there should be an ability to basically create a backup for all the volumes that an application uses. So if there could be some sort of a consistency group where the backup job for all the volumes can be initiated, that would be great. And when it comes to volume level backup, so it could also be realized with point-in-time snapshot, which can then be backed up. Finally, when it comes to Cinder volume, so differentiated volume types are realized by having support for multiple backends. And similarly, for when it comes to backup, so we might need differentiated backup services where you have different levels like gold, silver, and bronze of backup services depending on how quickly you want the recovery to be, how often you want the recovery to be, and all that. So what essentially needs to happen is Cinder should provide interfaces to actually surface the capabilities of different backup systems, and also provide the ability to basically configure different backends based on their capabilities. So to summarize, what is needed is rethinking of how data protection is realized in OpenStack, and have the right interfaces for backup and recovery in Cinder, and also think about backup of Swift data and other and the data blocks in OpenStack. And so it would be great if we could support live backup and differentiated backup services. And finally, in short, backup and recovery should be treated as first-class citizens today. Thank you.